Good morning, students. Let me continue our discussion. In last class, we discussed about relative velocity. Now, for the expression of relative velocity, we have used this figure. Now, in this figure, two objects, A and B, initially they are at a position x01 and x02. That is t equal to 0. Now, at t equal to 0, they have velocity at A. At the position x01 is v1, and at the position x02 it is v2. Now the two objects are moving. Now here we are considering that v2 is greater than v1, and now both objects are moving. Now at t equal to t, the position is your one is your x1, another one is your x2. And the velocity remains same as your v1 and v2. So the objects are moving with constant velocity. Now the expression which we have defined already have discussed in our previous class, that is your relative velocity of b with respect to a is your v2 minus v1, and relative velocity of a with respect to b is your v1 minus v2. Now the general expression which we have defined is your x minus x0 by t equal to v2 minus v1, where x is nothing but is your x2 minus x1, that is relative displacement of b with respect to a at t equal to t, and x0 equal to x02 minus x01, that is your relative displacement of b with respect to a at t equal to 0. Now we are going to use this expression to explain a few special cases. Now the first special case which we are going to discuss is your number 1, and in this case we have considered that v1 equal to v2. It means both objects are moving with same velocity. Now if both objects are moving with same velocity, then the expression which you have defined here, that is your x minus x0 by t equal to v2 minus v1. In this expression, v2 minus v1 goes to 0 as v1 equal to v2. So you are getting x minus x0 equal to 0. That is x equal to x0. Now x is your here nothing but is your as your derivation, x is nothing but is your x2 minus x1, that is your relative displacement of b with respect to a at t equal to t, and x0 is your x02 minus x01 as per in the diagram, is nothing but the relative displacement of b with respect to a at t equal to 0. Now in this case v1 equal to v2, so x1 or x minus x0 by t equal to 0. So it means x equal to x0. Now x is your x2 minus x1 and x0 is your x02 minus x01. It means you see the separation remain same. Whatever be the separation between a and b at t equal to 0, same separation will maintain at time t equal to t. Now here both velocity v1 and v2 is identical. So if we have to specify in the graph, considering y-axis as your position axis and time is your x-axis. So as per the diagram in the figure, x02 is higher, means it's far from the reference point O compared to x01. So as per in this figure, we have specified at t equal to 0, that is your x01 and x02. Now as speed is identical or velocity is identical, it means position time axis should be means the graph considering position time axis is parallel line. Parallel line in the sense, if I ask you to define the speed or velocity in case of displacement time graph, what you will do, you will find the slope. Slope is nothing but the inclination. So as v1 equal to v2, it means the position time graph for a, that is your x01, have inclination or the slope is same as that of x02 as specified in case of b. So if both the graph have same inclination with respect to the time axis, then definitely two graphs are parallel to each other. So that's why two graphs are parallel to each other, because v1 equal to v2 as specified in our special case. and x02 is always ahead of x01 because as per the diagram x02 is more spaced from the reference point compared to x01. Now next case number 2 which is going to define, that is your v2 greater than v1. So if we consider this equation again, and if we consider v2 greater than v1, so if v2 greater than v1, it means v2 minus v1 is positive. If v2 minus v1 is positive, it means x minus x0 is also positive. It means x minus x0 greater than 0. So we have used this parameter. If v2 greater than v1, it means the v2 minus v1 is positive, and as per x minus x0 is also positive. So if x minus x0 is positive, then x minus x0 greater than 0. So or x greater than x0. So you see here x2 minus x1 greater than x02 minus x01, as x is your x2 minus x1 and x0 is your x02 minus x01. So you can say as the time progresses, the separation between two objects, that is A and B, increases if v2 greater than v1. So if we have to plot the graph considering position time axis, then definitely x01 is in down close to the origin O, and x02 is above of x01. Now the graph in position time axis, the velocity or the speed can be defined by the slope. So as v2 greater than v1, it means v2 is for x02 as far from the figure. So v2 greater than v1 means the slope for B is more than the slope for A, because slope is nothing but the speed or velocity as far from your position time graph or displacement time graph. So what happened basically, as the separation increases with respect to time, that's why the graph is spread out. Both graphs A and B spread out with respect to time. Now next one which you are trying to define, this case, that is your v2 less than v1. If v2 less than v1, what happened in this figure? v2 minus v1 is your negative. It means x minus x0 is your negative. So if x minus x0 is your negative, it means x minus x0 less than 0. So x minus x0 less than 0, or x less than x0, or x is your x2 minus x1, x0 is your x02 minus x01. So you can say the separation between the two objects A and B decreases with respect to time. So you see in this figure again, x01, x02, x01 is in close to the origin and x02 is above. So you see v2 less than v1. So for A, the slope is more compared to slope for B. So if slope for A is more than for slope B, what happen? A time will come when the two graphs will intersect. So intersecting point define the meeting point of the two objects, and corresponding position is nothing but the position at which the two objects will interact. So it is obviously if v2 is less than v1, so definitely they will intersect or collide. So these three graphs are very important as far your exam point of view, and sometimes it is asked to explain with respect to the graph. I think we have understood. The common thing is your what? The in position time graph, the slope basically define the speed. That's all. And if the inclination is high, it means slope is high. It means velocity is more or speed is more. So you see next note, under note, when two objects are moving in opposite direction. In this figure or in this diagram, we have considered two objects are moving in same direction. So if two objects are moving in opposite direction, how can we define the relative velocity? When two objects are moving in opposite direction, it means if we consider v1 is positive, v1 direction is positive and v2 direction is then definitely the negative direction of v2 is opposite to that of v1. So if v1 is positive, then v2 is negative because both objects are moving in opposite direction. So under that case, the general expression which you have defined as your VAB, v1 minus v2. So v1 minus of v2, so v1 plus v2. So if two objects are moving in opposite direction, then the velocities gets added up. to define its relative velocity. So similarly in case of VVA, so if V1 is positive and V2 is negative, then minus V2 minus or minus V1, so V2 plus V1 with the negative sign. So if two objects are moving in opposite direction, the relative velocity added up. If two objects are moving in same direction, the relative velocity is nothing but the difference between the two velocity. So this is all about related with the relative velocity as described in this chapter. More relative velocity we will discuss in vector when we discuss motion in plane. So please go through this topic and try to find out your doubts and make your habit to ask questions during the class, because many of you or only few used to ask questions, and rest people I don't know what you used to do. So you must be present in the class and simultaneously you have to study, and if you study then definitely you can ask the question. This is all about. Thank you.